All right, so this time we're going to calculate standard error. In order to calculate standard error, we do have to have standard deviation, so this would be a good chance to practice that. So the first thing we need to find is the mean. So you add those together, divide by 5, and that's going to give us a mean of 10. So if you'll remember, standard deviation, the formula is the square root of the sum of each individual x minus the mean squared over n minus 1. Don't have to memorize that, it's on the formula sheet. All right, so minus 10, I'm subtracting the mean. I'm going to square it. So that's going to be negative 4 squared, which is 16, 2 squared, which is 4, 5 squared, which is 25, negative 3 squared, which is 9, and 0 squared, which is 0. Okay, so I've taken each individual x, subtracted the mean, squared it. Now I need to sum those up. So 16 plus 4 is 20, plus 25 is 45, plus 9 is 54. So that's my top, and now I need to divide by n minus 1. I had 1, 2, 3, 4, 5 was my n. So minus 4, and then don't forget the square root. So that's going to be the square root of 13.5, which is 3.67. Okay? That is my standard deviation. Standard error, okay, another formula you don't need to memorize, is going to be standard deviation divided by the square root of n. So once you have your standard deviation, 3.67, divided by the square root of n, which was 5, not n minus 1, n. Okay, so square root of 5 into 367 is 1.64. Okay, so that is my standard error. All right, so that's the first thing, is I can calculate standard error. The second is I can explain how standard error can be used to accept or reject my null hypothesis. All right, in order for us to accept or reject, we're going to need to live in the world of plus or minus 2 standard errors, because that is where I am 95% confident, which, stretching over to chi-square, is the same as saying I have a p-value of 0.05. And if you'll remember, that's where science says we have to live. This is saying there's a 5% chance it's due to randomness, or I'm 95% confident that my results are not due to randomness. Okay, so this is saying the same thing. Well, I have a standard error of 1.64. That's one standard error. I'm going to need 2 standard errors in order to get me to this 95% confidence. So I'm not going to round this time. I'm going to be a good person, good science person. I'm going to do what I'm supposed to do, not round. Times 2 is 3.28. Okay, so that's going to be 2 standard errors. So when I'm graphing this, I'm going to graph my mean of 10, and I'm going to go up 3.28, and I'm going to go down 3.28, okay? So just to get us a little ahead, and graph some of this. Don't pay attention to this line. This is data I made up. But what I wanted you to see is when we add these standard error bars, so I'm going to go up to 13, so 10 plus 3.28 is 13.28. 10 minus 3.28, and I've already done the math, so I know that, 6.72, okay? So that's where my standard error bars need to go up to 11, 12, 13.28, and then down to 6.72. So this is, oh wait, I didn't go the right place. Each of these is 1. I mean, each 2 is 1. So this is 1, 2, 13 point, okay, it should be right there. Okay, ignore all those other lines. It's the dark one. All right, and then down to, this is 5, 6.72. Okay, so that, okay, so this is my range for that one, okay? Now here's this other data that I have. This is my range for that one. What we notice is there is an area in which these 2 ranges overlap, okay? Because they overlap, that means there is not a statistical difference, and we have to accept our null. So that's how we use standard error bars. We're going to have at least 2 groups to compare. We go up 2 and down 2 for each group. This one had a standard error of 3, so I went up 6 and down 6. And because those standard error bars overlapped here, that means there is no true statistical difference, and I have to accept my null. Yes, they look different, but statistically they're not. So now let's look at another one where they are different. So here I have my graph. I'm going up, same thing, 13.28, so 11, 12, 13.28-ish, and down to 6.72, so that's 5, 6.5, right in there. Okay, and so my range this time is there, and this range is here. So now if you look, there is a skinny little area right here in which they do not overlap. It's above the top of this one, it's below the bottom of that one. And so because they do not overlap, for this one at plus or minus 2 standard error bars, I would reject my null, which means there is a statistical difference. It's not much of one, but it's enough that there is one. And so that's how you would use standard error bars to decide if you would accept or reject your null. You would go up and down 2 standard errors for both groups, and then you would see if there is an overlap, accept the null. If there's no overlap, you reject the null. And I hope that helps, but if not, you have questions, let me know.